Hey, you lovely lot. I'm Teacher Jess, and welcome back to Geo Cafe. So, what we are going to take a look at today is a grade 10 topic. We are going to look at the greenhouse effect and the topic of global warming and climate change. I know that this is a topic that there's a lot of information on. There are loads of videos and loads of resources that explain it very well. But I'm still quite surprised to see how many of my students actually don't know the basics of the greenhouse effect and why climate change is a big conversation. So I thought I could do this is more of like a 101 version of what the greenhouse effect is, why it's very important, and how we get to global warming. Okay, let's dive in. Before we can actually understand global warming and climate change, we first have to take a look at the greenhouse effect. So the greenhouse effect is a very important process that has to happen in our atmosphere for us to be able to survive here on Earth. Basically, it's a process that traps and holds heat in our atmosphere and keeps our Earth at a livable temperature. So it is a necessary and natural part of the heating process that helps keep us alive. And to go into it, I actually found a really nice simulation. This website over here, it's PhET website that provides different types of simulation for education, and it's really cool. And I found these two different simulations that I thought could be very useful for explaining the greenhouse effect. So, what we need to understand before we understand how the greenhouse effect works is how the different types of light react to the different types of gases that we get in our atmosphere. Now, I know I mentioned this in an earlier video where I was saying that the sun doesn't heat the atmosphere, not directly. And what I mean by that is that the incoming UV radiation from the sun actually doesn't get absorbed or not significantly absorbed by the atmosphere to warm it up. And so what we have over here is supposed to be a demonstration that shows that. So I've got a little ultraviolet torch, and this is supposed to be different types of gases. So I'm going to start with nitrogen. Nitrogen is the most abundant gas in our atmosphere. It's about 80%. And I'm just going to turn the little torch on. There we go. And there you can see it's shining the light, and the light is just passing through this gas. It's just passing over it, and it's not really reacting in any way. Nothing's happening. So let's try a different one. Let's put in some oxygen. And we can see it's the same thing. Our most popular greenhouse gas, carbon dioxide. See? Nothing. And let's put in some water just for good measure. Okay, we get the idea, hopefully. The other type of light that we need to understand is infrared. Infrared is what the Earth emits. So the sun releases ultraviolet, it is absorbed by the Earth's surface, and then the Earth uses that energy to produce its own type of energy, which is terrestrial radiation or infrared. This is what we can feel. This is the heat. So this is also why it is hot closest to the surface of the Earth, and then as you go up in the atmosphere, it gets cooler because the surface of the Earth is where all of the infrared and the heat is coming from. Let's see how this reacts to the different gases of the atmosphere. Okay, nothing in nitrogen, nothing in carbon dioxide, in oxygen. And now let's get to carbon dioxide. Okay. Do you see how the molecule absorbs and re-emits this infrared energy? And it scatters it into different directions. Let's try water. Same thing. Methane. There we go. So you can see how these different gases, these particular greenhouse gases, interact with these different types of light. This is an important basic to know because we are going to take a look at the bigger picture of the greenhouse effect. And I want to see if I can do it with a diagram over here. I don't know how well it's going to work, but we're going to give it a try. I haven't tried diagram on Canva before. So this is supposed to be our Earth over here, and this little green circle around it is supposed to be the greenhouse gases, the atmosphere. Now let's maybe put in a picture that's supposed to be the sun. There you go, you look nice and pretty. Okay, we've got the sun over there, and the sun is releasing solar radiation. We also refer to it as insolation, incoming solar radiation, and it is UV radiation. So this is the UV radiation coming in, and it's just passing right through the greenhouse gases like we saw in the simulation. It just passes over them, doesn't really react, and then it gets absorbed over here by the Earth. Then the Earth also releases its radiation, that's terrestrial radiation, or some of it escapes. You did see that some of them passed by the molecule, and some of it bounces back. I think if we have 2 arrows going out, we should probably have 2 arrows coming in as well. It's not the best drawing, but we get the idea. So there we've got our incoming solar radiation. It gets absorbed by the surface of the Earth. Some of it gets reflected, but we're just going to say most of it's absorbed now. Then the Earth emits the terrestrial radiation or the infrared, and that then either escapes through the atmosphere or it gets reflected back and absorbed by the greenhouse gases. This is when everything goes well. And I found another nice simulation over here. I thought we could give it a try. I saw this over here. I thought this might be a nice idea. This over here, I can see the different times, or like, going back in time and seeing what the atmosphere and the greenhouse gas concentration was then, and how the temperature balance would have differed. Let's just go right back to the ice age. We can see all of the ice. The ice would be very reflective, so a lot of the UV radiation would be reflected out again. We can see the incoming solar radiation is supposed to be in yellow, and that then reaches the Earth or is reflected back. You can see some of it there is reflected by the clouds. And then the terrestrial radiation is red, and that's what's warming the Earth. I'm assuming that this arrow pointing downwards is how much energy is coming in. This going outwards is how much energy is going out. And then the net is if there is more coming in or more going out. So let's take a look. Let's push play. And it looks like it's reaching a balance, almost. And it seems to settle in a temperature over here. 7.1 degrees Celsius. I don't know if you can see that. But over here we have 7.2 degrees Celsius. So that is the general temperature of the surface or the atmosphere at the time. So we can see quite cold. By 1750, I'm assuming the main difference over here is more the ground cover. We don't have any of that ice reflecting the sunlight backwards, so there's more energy being absorbed. Let's take a look. Yep, notice it's getting a lot warmer. 12 degrees, 13 degrees, starting to go up. You can also see a little bit on the thermometer over there. And I think it's reached its balance. Yes, okay. So by 13.5 degrees equilibrium, so we can see it's definitely warmer without the ice. More of the incoming radiation is actually being absorbed by the ground, producing infrared. Then let's go to 1950. So this would be after industrialization, and now we start to see the effects of emitting more greenhouse gases. Now what we should see is more of this red being reflected back again. More of this will be trapped in the Earth's atmosphere. So let's see. And then the temperature should go up. Okay, it hasn't really gone up very much. It's gone up by 0.2 degrees. Then let's take the last jump to 2020. Okay, now it's gone up quite a lot. 14, almost 15 degrees over here. So there it did increase. So these little animations of here are supposed to show you the increased greenhouse effect, the greenhouse gases, and then our temperature is going up. Let's see if it balances out. It looks like it's settling on 14.9. Okay, we can manually change the level of the greenhouse gases as well. So let's go really, really low. Let's bring that all the way down. And there you can see the thermometer is dropping. It gets really, really cold. You see most of this red is going out. Very little is actually staying behind. And then as we bring that back up, suddenly the red is being trapped in the atmosphere. You can see more and more is staying here close to the surface of the earth, and very little is actually escaping. And now you can see the temperature going up again. So let's go back to our diagram and our notes, and let's see what the notes have so far and what I might be missing from my diagram. Insolation passes through the atmosphere without heat being absorbed. That's the incoming solar radiation, and then is absorbed by the earth. So the earth absorbs the insolation. We did have that in our diagram. Earth releases heat by long wave radiation, so that is our terrestrial radiation. And then greenhouse gases absorb the heat from the long wave radiation, and the atmosphere is heated. Like I said, this is a very necessary part of the atmosphere. This is what keeps us warm. This is what keeps us alive and makes Earth habitable. This balance that we've got is very critical. All life and climate and all of that has settled around this balance, which means that if we are adding more greenhouse gases, it's going to throw the balance out. Let's just add another layer of greenhouse gases, which means that if we have incoming solar radiation, it means that the Earth will be receiving more energy to produce heat, and more infrared will be trapped in the atmosphere by these greenhouse gases. Okay, which means overall temperature increases. If we have too many greenhouse gases, it can throw off the balance, temperature increases, and a lot of human activity is contributing to these increasing greenhouse gases. And this is where we get to the topic of global warming. As more and more of this infrared and this heat is trapped in our atmosphere, the overall average temperature starts to increase, kind of like what we saw with that simulation. When it was its lowest, it was like 7 degrees, and as it increased, it got to almost 15 degrees. And that might not sound like a lot, but in terms of an entire globe, an entire atmosphere, it's a lot of energy, and it can throw things off balance very quickly. A lot of our industries and our activities release these greenhouse gases. Carbon dioxide is always the most popular one that people talk about. We also have methane and water vapor. All of those are greenhouse gases that do contribute to the greenhouse effect. Looking at what causes global warming, one is the incredible dependency on fossil fuels that we currently have, and using those fossil fuels, burning those fossil fuels, releases a lot of carbon dioxide into the atmosphere, as well as using it, and that's just like in industries, as well as using it in different forms of transport. Methane we'll take a look at, but that's more focused on farming, as well as nitrous oxide is also linked to the farming and agricultural industry. And then deforestation, that is a double culprit. It contributes to global warming in two ways. One, it actually stops vegetation from reducing carbon dioxide, but the actual use of the chopped down forests also contributes to carbon dioxide increase. As we become more industrialized, and this is globally, all countries are starting to move more and more into an industrialized era. We are using more fossil fuels, we are using different forms of energy, and these produce a lot of air pollutants and primarily carbon dioxide. As we burn these different forms of fuel like coal or oil, we do release more carbon dioxide. And it's not just in the industries, it's in our transport as well. As we become more dependent on having our own cars and different private forms of transport, we do contribute more to carbon dioxide and the greenhouse effect. I always like to ask this as a question to my class because very often we have a student that asks about electric cars, and I ask them, is it really cleaner? And very often students will talk about the environmental impacts of making the cars. And yes, that's definitely something to factor in. The footprint of the batteries, I know they're very demanding and needing specific metals and specific elements to get the batteries going, and they can have quite a carbon footprint just making the cars. But my question is actually about running the cars. I had a conversation with someone in South Africa saying that they wish they could have a hybrid car. And I asked why. And they said because it's cleaner, it's better on the environment. And I asked them to elaborate. And they said, no, with the electricity, it can reduce their fuel consumption and all of that. I said, okay, but in South Africa, where do we get our electricity from? And they thought about it for a moment and they realized from coal. So we can't really say that electric cars are cleaner if the electricity is produced using fossil fuels. Now, that's not to say that it can't be cleaner. I'm taking out all factors of production or breaking down or everything else. I'm just looking at the actual lifetime use of the car. It can be cleaner if we can produce electricity without fossil fuels. So there's another problem that we just need to get over first. And in South Africa, we're still very dependent on coal. We really need to invest in other types of energy sources, but we're a bit slow. That's not to say that the electric cars are, a bad idea altogether. I'm not saying I'm opposed to them at all. They just still have some way to go. And countries like South Africa, we have some way to go before we can see the full advantage of something like this. Then we get to methane. Methane is a very effective greenhouse gas. It stores up to 20 times more energy than carbon dioxide would. And this is generally linked to agriculture. So things like rice paddies. These farms where they grow this rice, there's a lot of decomposition and bacteria and everything that's happening in the water that produces a lot of methane. So as it's breaking down the organic material, it produces methane. And it's the same thing with cattle and other livestock. As they eat and produce gas, that gas is methane. And yes, the amount that we farm, the amount of cattle and livestock that we have is enough to actually increase the methane in the atmosphere. Then we get to nitrous oxide. Nitrogen is a very important part of farming. It's a part of fertilizers, and fertilizers, help the plants grow. I think nitrogen is used for the roots of the plant, if I remember correctly. A lot of chemical fertilizers have nitrogen in them, and this nitrogen can be a pollutant in many ways. And one of them is that we're seeing more nitrous oxide. It's another greenhouse gas that we're seeing from these chemical fertilizers. And as our population is increasing and as more people are needing more food, we are obviously farming more. We have more industrialized farming, which means that more and more chemical fertilizers are used for farming. And then, of course, deforestation. I always love to use this picture because of the visual representation of the lungs. We're needing the rainforest and the trees and all of our vegetation for photosynthesis because it not only reduces carbon dioxide, but it also produces oxygen, and we need that to breathe. I like to be able to breathe. not only are we removing these carbon sinks, so it's less carbon dioxide being taken out of the atmosphere, but the reason why we're removing these also increases the greenhouse effect, the greenhouse gases. This was just a very interesting graph that I found, and I want to go back to this website to see what else we can find about deforestation, why we have deforestation, and it's kind of scary to see that most of it, 41% of deforestation, goes for cattle, grazing land for cattle. So you can see all of this is just beef, beef, beef. And then next one is oil seed and then forestry. So it's not even as much that is going towards paper as you would think it is. Usually the students say deforestation is for paper. Deforestation is primarily for the space, for the land. Doesn't make sense in my mind why we would be chopping down this very important ecosystem for open space when I'm pretty sure there's loads of open land somewhere else that's available, maybe better suited, and wouldn't leave such a big carbon footprint. And then, of course, let's not forget that the cattle themselves then contributes to methane production. So there's like three different ways that beef and agriculture is contributing to greenhouse gases. So usually about now, I've got a few kids not understanding how global warming is a thing when winters are colder and this is this and this is this, and now we've got snow here and in places that we've never had it before. So I quite like this picture because it makes me think of where's global warming when, I've got snow in my backyard for the first time in 20 years. Okay, that is not necessarily a global warming thing, but a climate change thing. So I just want to take a moment to explain the difference between global warming and climate change. Global warming is from the greenhouse effect. What I mean by that is that global warming basically just describes how the greenhouse effect is trapping more and more heat. Don't think of that heat or that warming as actual temperature. It does contribute to the overall higher temperature, but don't just think about it as temperature. Think about it as energy. The more energy the atmosphere and the surface of the earth has, the more extreme and exaggerated things can become. That is when we get to climate change. Climate change is the long-term knock-on effect of global warming. As things become more extreme and more out of balance with this excess energy that's just making everything exaggerated, we are having more extreme phenomena. So we are having stronger hurricanes and drier droughts and wetter floods and all of those things. So I just wanted to clarify the difference between global warming and climate change. And I try to refer to climate change as much as possible, just so that they understand it's not just a temperature related thing, it's an entire system being knocked out of balance. And then what are some of the impacts of climate change? You can't be talking about global warming and climate change without having the little polar bear bobbing around on a block of ice and, pulling on the heartstrings a little bit. But the reality is that a lot of animals are losing their habitats. Without them being able to adapt so quickly to this changing climate, they are going to be dying out, they're going to be losing their homes, and we're going to see more and more species become extinct. And that's not just, the cute and cuddly polar bear. Please don't go hug a polar bear, they are dangerous. But it's not just the cute and cuddly polar bear, it's also the tiny little critters, the insects and the animals that help keep us alive. We are seeing more ice melting, which means rising sea levels. And rising sea levels, it sounds so vague, but we have a huge portion of the human population that lives on coastlines, and they live in this area that could be at risk of rising sea levels, which means that people would not only be forced to move from their homes, we would have a lot of businesses, industries, farms, all of these things at risk of flooding, losing a lot of our natural resources, and in a lot of cases, there is nowhere else to go. We can argue and say, oh, just move and land. But in some cases, if we're looking at islands, there is nowhere else to go. There is no other inland to move to. We have changes in weather patterns, which can have a knock-on effect with droughts, fires, flooding, etc. The countries that are especially vulnerable to these changes are your less economically developed countries, where they don't really have contingency plans in place in case of a flood or a drought. They don't have a lot of water available to manage, or maybe they don't have good infrastructure in case of floods. So if a disaster hits, it's quite devastating. It has a very far-reaching effect on the people, on the economy, and it's very difficult for the country to bounce back again. And unfortunately, these disasters are becoming more frequent. But this wasn't supposed to be a doom and gloom video. It's not all about, ice caps melting and rising sea levels. There is a lot that we can do as a population and even as individuals. Okay, so one thing we can look at is providing rewards and incentives to reducing greenhouse emissions. And this could be something like some type of a tax reward or a tax credit. We should also be looking at different forms of energy production. We have solar power, we have wind energy, all of those options. And even though they look expensive now, they're worthwhile investments for the long term. We should be conserving our natural vegetation and planting trees. I am always hesitant to add in the planting trees thing. Planting trees, it needs to be done in the right context for that environment. So when we're talking about planting trees, we should absolutely be planting them in your forest areas where there has been deforestation, like our tropical rainforests. But in places like South Africa, where we're a very dry, very arid country, trees are quite demanding and quite taxing on our water supply. So a lot of trees are being cleared because of the impact that it has on the natural vegetation. It just leaches and drains all the water supply and also completely devastates the biodiversity of the indigenous plants. So planting trees, it needs to be done in the right context of that environment. Otherwise, just having more indigenous vegetation. Then recycling products, just actually recycling our own things, putting things into the necessary bins, and then encouraging industries that do produce recycled material. There's far less greenhouse gases emitted from recycling material than there is from producing products brand new from scratch. So supporting recycling either by contributing to recycling or by buying recycled products, or a good way to go. And then the spreading awareness. This is the small scale. This is what we as individuals can do. And it can be little things like just conserving electricity, or maybe joining lift clubs instead of driving individual cars, drive in groups or something like that, or walking where necessary. So I wanted to see what I could find on global warming and the greenhouse effect on our world in data, and just see what kind of interesting diagrams they have. They've got some really interesting graphs and maps. And let's see what we can learn from this. So this, we have the increase in annual temperature. We can see that beautifully plotted graph and how it slowly increases. You can see it's got a margin of error, so a range that the possible projections are in between. You can see as we go further back and the information is probably less reliable, they have a bigger range. And as we move into more current day, you can see this gap between the gray and the red becomes a lot smaller, so we're more confident about what the temperatures then were. Very clear to see, since there was some type of industrialization here, there it increased quite a bit. This is countries contributing to greenhouse emissions. So let's see. I think it's well known that the United States is like one of the biggest contributors. Then we have China coming up quite quickly. Let's just bring this down. So we've got China here as well, going up quite quickly. So some type of industrialization must be happening over there. United Kingdom is going down. I wonder what they're doing. They must be, maybe they're just making steps in the right direction. I'm curious to see where South Africa falls into this mix. Okay, South Africa is going down. South Africa is not as developed yet as it should be. So it's a good thing that they're not producing greenhouse gases or that it's starting to decrease. But it also tells me that the industrialization is slowing down. And I don't think that's a good thing for South Africa's development. So you would expect to see a spike with industrialization and then slowly starting to, there it is, the blue one, and then slowly starting to come down as they find cleaner and more environmentally friendly ways of being industrialized, unless South Africa is trying to develop with a lower carbon footprint at the same time. That could also be a factor. Okay, yeah, it was increasing over there. It started decreasing 2007. I'm very curious about why it's actually decreasing. I can't see why it would be. I was curious about Brazil because of the deforestation. You know, that's where all the deforestation is happening. So what kind of impact would that have on their greenhouse emissions? And we can see it is increasing, stabilizing, but not really decreasing it. Where else can we go? Let's see, France. Wow. Oh wow. Okay, wait. Let's go back to that. I want to remove some of these other ones. I'll leave the world in. But look at that. Okay, so France was it peaked and it's like it came to the party really, really quickly and it's just been decreasing so much. That is amazing. Wow. But it has increased, it is stabilizing, starting to decrease. I wonder if this is just a movement towards being more environmentally aware. Annual carbon dioxide emissions, including land use change. We can see who the highest producers are. It's interesting to see how low some of the MEDCs or the more developed countries are. You know, this is the higher end. You can expect that. Yes, a lot of industrialization or very industrialized countries. And then it's interesting to see how South Africa falls into the same group as Australia and a lot of European countries. Although I do chalk that up to the fact that we're not very developed. Oh, this is actually something interesting. So per capita means that it's divided by the number of people. So obviously the more people you have, the more carbon dioxide or greenhouse gases you would emit because you need to support more people. So if we're looking at providing food and farming, you would have more methane and more nitrous oxide because you're farming for a bigger population. So per capita then divides it by the population to see what is the greenhouse emissions then per person of that country. And we can see that the top emitters are still the top emitters, but Australia now falls into that. Ah, Australia is now in the top end. So even though they produce less greenhouse gases overall, in terms of the per person, it's actually a bit more. South Africa is still more or less in line with Europe and Namibia. Okay, and then who's on the low end? A few countries there, a few countries in Africa. Interesting to see India on in more the middle area since it was in the higher end for the production, the greenhouse gas emission. Was it here? Yeah, there. See, it was one of the higher producers, but per capita, it's on the lower end. And again, that's because of the population size. Because India, I think, is the most populated country. Yeah, it's the most populated country, so obviously divided by a lot of people, and then it's less per person. Like I said, I know that this topic of global warming and climate change, a lot more depth to it. There's a lot more that we can dive into and discuss, but this was just supposed to be a basis just to understand what the concepts are and what we are talking about. A lot of the different topics of geography, like when we get to floods and droughts and loads of different things, they all have connections back to climate change and global warming. And hopefully, this is just a good reference point for all of those conversations. Okay, well, then I hope you have a lovely day. I hope you learned something and maybe had a few questions answered. And I hope to see you again next time. Cheers! Bye!